Wait till sir not reach yet. I will palm Melissa or something. Make him not reach already. Normally early.
Good evening, everyone.
Hello, good evening. Button there.
Evening, sir.
Good afternoon, all.
Good afternoon,
Afternoon,
sir.
sir.
How are you
Good
today?
afternoon. Not good,
Afternoon,
sir.
sir.
Not good?
I'm,
Why aren't you good?
I'm anxious.
You're anxious? What are you anxious about? The Bible
You've been
says,
too quiet, sir.
I've been too quiet?
Yes,
Yes.
sir.
The Bible says,
And it's not sleep, yeah? Sleep, I'm sure about that.
Sir, oh, you so quiet, Powie?
Jesus.
Yeah, I've I go boom.
All right, see me so. Well,
Sir, I'm mad in front of you, sir.
You see, I don't know how to do it. I don't know how to, as a matter of fact.
So till we did say I have an malice.
Malice. No, man. The truth
I
of the matter is, I saw the messages or the message that says that, boy, you know, my word's not theirs. The silence is kind of deafening, and I just kind of chuckled. All right, so the papers have been marked. I will not discuss the papers today. I will review the papers.
So you send out the grades too?
I have not sent out the grades officially, but some students did very well. When I say very well, big hug up for no.
Thank you, sir. Thank you.
Some students did very well. You know, most of you did okay-ish.
Jesus.
There are one or two, 3 or 4 or 5 students that I'll have to have a private conversation with. So private a conversation that.
All right, so we're not going to ignore it.
So private a conversation
that. Yeah, these bad words.
Same as so Jermaine.
So sir, that means I'm not getting a hug up then.
The truth is, all right. So as I said before, I marked the papers. You know, I know I know 2 students in the class are going to be upset with me, but I'm just going to put it out there that it is fine. You can be upset with me, but I'm going to tell you that you're not going to be upset with me for far too long. One of you made a grave mistake and you were penalized for it. One of you made a silly mistake. And matter of fact, I think me should have put on the malice face first so that when I give the results, me already in malice with you. So if you in malice with me, it's not a problem. If you decide that you're not going to be in malice with me, I will get rid of the stuff. Same way stuff. But So one student I know, well, two students in particular, are going to be upset with me. I'm a little upset with some of you because you didn't follow my instructions. Really did not follow my instructions. I went ahead and looked at the recording and I saw where it was viewed 43 times. And I'm saying I have 22 students in the class. So I'm going to say 21 of you viewed it twice, and the one student in the class viewed it once. I am pleased. For the most part, I am pleased. I have, however, a handful of students that I am concerned about, and as a result of that, those students and I will have a private talk. I want to put into the group. Yannick touch base with me because I'm against the blow or Yannick sir want to talk too. So I will somehow discreetly.
Sir, just call me name and done, man.
Sir, no worry, Ed. I know when you run them joke, they're serious though.
Yeah, so just call me name and so say Kelvita, we need to talk this week.
Oh, Jesus, Lord, I love you. So
just say Kelvita, we need to talk this week, sir.
I may start my talk today. As I said before, you know, I'm not teaching you guys for 21 of you to pass and one person fail. That's not me. Every striking one of you will be moving into calculus 2. Whether or not I'm teaching it, but when I pass my calculus 1, I have you here and you're going to pass. So those handful of students that disappointed me, we will have conversations. You have to promise me thereafter that you're going to be improving on the academic performance. I don't care where you're from. I don't care how much you don't like math. I don't care about anything of the sort. What I care about is pretty much you putting up your, you know, what that begins with D and ends with Z, and doing what you're supposed to be doing. All right? So, but outside of that, on a whole, the class did okay-ish. On a whole, some students did very well. Yeah, but
Sir, I reach out from a night. I see my mistake long time, sir. So I know already. I see where I go wrong already, sir. I reach out to you from the night.
Me not call a name yet.
Sir.
Yes, please.
Sir,
yes,
what's the highest grade?
What's the highest grade?
Yeah, marks so far.
98%.
Sir.
Sir,
Charlene, are you that?
No, it's not me.
But I am not wasting any more time to talk about the test.
Sir, 1 minute, sir.
Yes,
somebody
yes,
ever interrupt me. Sir, I had a little technical difficulty. Sir, so I hope it now affect my grade.
No, man, I saw your questions. I saw
sir, see all of them, sir.
I see all of them. It's just that some of them I put in 2 times and 3 times. So you see when I'm at the paper, you'll see me write duplicate across it.
Sir, so every single question you get, sir?
Yeah.
All right. Thanks. Sir, my one too? Okay.
Can we move on from here because you see all boy. So
you know, some me want to talk to you. Is that right? You talk.
I don't even know what you're talking about. But anyhow, there are some of you in the class though that even though you didn't get the 90% or the 90+%, I am very pleased with what it is that you would have gotten, because I know, trust me, a teacher has a way of knowing based on the questions that we talk about in class. You know, I see where the maturity is developing. I appreciate the effort, I should say. As I said before, it's just a few of you that may just need to talk to. And then when I speak, when I speak to you, I don't want you to go through one eye and come through the nether eye. I want you to internalize what it is that I'm saying. I make comments on paper. I'm going to be uploading your marked papers so you can see what it is that you have done. Depending on how I feel, I may start uploading those papers today. What I need to do is just to cross-check the records. What I have on paper, I just need to cross-check to make sure that that's what I'm seeing, that's what I have recorded before I distribute. I don't want to say somebody get 50%, but in reality is 45% the person got. And then when I reduce the grading, you say, but sir, I saw 50%, right? So I just need to do that. That's all that needs to be done. And then I'm out of it. So what I promise you to do is, I don't want to discuss it now because I want to give you time enough to go through the paper. So I'll start distributing the paper. As I said before, it depends. If not before 9:00, you know my time. It can be maybe 1 o'clock, 2 o'clock tomorrow morning, God's willing, that I'm going to do that. I want you to be responsible and not just look at the grade. Be responsible to see where it is that you would have made those errors so that you don't make those errors again for me. Some of you literally just don't listen when I speak. And that's one of the reasons I really want you to participate in class. There was a student who asked a question, sir, I'm having a difficulty understanding this. Can you do this one, please? And I said, okay, fine, let me do it. And when I marked the paper, I was pretty pleased. The student got full mark for the question, and I'm saying, thank you, Lord. So, you know, the responsibility is yours to do what it is that you're supposed to be doing. You cannot sit into my class and not pass my course. It does not happen. All right. I think I'm a patient enough teacher. I think I teach with clarity. I have given you everything that you need. The recordings, you don't have to ask me for recordings. You don't have to ask me for notes. You may have to give me a gentle reminder, but I know some lecturers may have a difficulty getting the recordings to you. I make sure to put the recordings in a safe place so you can always go and access those. You have access to my soft copy notes. I don't know what else to do. I'm here every day for class. If I'm not in a good mood, you don't know whether or not I'm in a good mood. Miss Kelvita is a fly on my wall. Sir, I don't like what you answered me today. And I said, oh, crap. You just can pick up, right? But you know, so I'm happy. And you know, anyway, let me not say anything more. So this is it. I want to complete my unit 3 today. I was speaking to my assistant today to say to her that, can you believe that on Thursday, all being well, I'll be starting my unit 4. I am confident that I am not rushing through the syllabus because based on what I've seen, I'm confident that you guys are understanding. The 5 or so students that, you know, I have concerns about, I will speak to you one away. I will create what we call in education an individualized education plan for you. So it means that I'm going to give you additional work outside of what it is that we're supposed to be doing to catch you up to speed. You don't have to do it. If you don't do it, you're left alone. But you need to do this so that you can catch up with me and the other students in the class. Outside of that, I think we're moving on at a steady pace. I really want to finish the syllabus. Your exams will be in January. It would be nice if I can complete the syllabus by December. And we can spend the 3 weeks in January meeting. By then, I don't think we have to meet until 10 o'clock on a Thursday. We can go back to our 7 to 9 or even 7 to 8:30 to spend an hour and a half to just work past papers, anything the man give on the exam, we're supposed to be able to shell it, right? Some of you already are going into the exam with a very good grade for your mid-semester. So, yeah. Okay, so enough of that. Trust that. Yes, sir. Go ahead.
That gang of 5 days, sir, with the extra vibes that we all give them. They like for join it still, you know. Because still need it.
You have to buy a beer or 2 to get in.
That's simple thing that am I language you're talking about, sir?
And Kelvita to don't.
Yes, sir.
Let us move on. No, Kelvita want the whites, but let us move on. All right. So we have oh crap, no, I don't want to read on the side.
Sir, before we move on.
Yes, Miss
Sir.
Yes, Miss Ma'am. Yes, Miss Ma'am.
Sir, am I going to have to fast and pray for you to fix up Edico South so I'm not stress out in December for complete all of them assignment there?
Fast and pray and ask the Lord to give your teeth. You see, I could have done it already, you know, but I decided that I'm sitting up to mark and go through the papers. And I say, no, this must come out of the way. So I cannot, okay, so what I can do for tonight, I can just sit and work on Edico and then delay those papers a couple more days. Which one you choose?
Today is Tuesday.
And I
let the class go. No, make no decision for the class. So,
I love it. I love it when I give you. And also, yeah, man. I'll have it done. Don't fret not. It will be done. It's just that I remember, and then I sat down, and every time I was supposed to get up to go and do something, I said, nope. I'm marking these. Oh, there were a few of you who, after me done telling us to convert the synthing to a Microsoft Word document, preferably. If you can't do it, send the PDF. Some of them will still upload photos to me. I beg so till. But I will forgive you this time. You know yourselves. You don't need to call a name or identify yourself. You know yourselves.
I'm sorry, sir.
You need to follow
I am sorry, sir.
You need to follow instructions. All right. So with that said, let us go. All right. So we're looking at so I'm wrapping up my differentiation. Not that differentiation is going to be finished after today. It's just the rules really and the things that we're hey guys, I only for work with you. It's just the rules really for the differentiation that I'm just wrapping up, and then we venture into some other, you know, big stuff of differentiation, because we're going to be looking at applications to differentiation, where it is that we're going to be doing, you know, some stationary points. We're going to be looking at things that are, you know, maximum, minimum, and saddle, you know, etc., etc. So we are going to be looking at those, and once we look at those, you know, we will be fine looking at the applications to the differentiation. So I want you to read through this for me. I'm going to ask you for 2 seconds. I want you to read. Well, let me not say that because I know it was up and you guys would have read it already. So let me just go. Square root function is not difficult. This is where I want to get to. Square root function, I'm just going to give you that. This is what I want to get to tonight. I have an hour and a half left, and I want to spend an hour on my implicit differentiation. Implicit differentiation, nice. Very nice. It looks awful. It looks like enough letters. You wonder how you can find d by dx out of this ugly looking stuff. I wrote some questions for you today. Jesus, did I save them? So in the midst of finalizing your paper, 2 questions came to mind, and I wrote it, and I put this little curvulus one inside there, and I say, no, let me see how well they're going to do that for tonight. So let us see if we can go. This one is not bad. Let me just give you some orientation on this one, work an example with you, and then give you 1 or 2 to do in class. By 6 o'clock, we should be finished with that, so I can move into the implicit, officially finish off. Finish off the differentiation. And there are some other little things that I need to touch on. So, you know, those little granular stuff I will get into the mix. All right. So square root function. You know what the square root function looks like? It is this function. It is this
You're not sharing.
Oh, I knew that. I just did that to see if you were actually paying attention. Forgive me, Lord. So the square root function, the square root sign, symbol is this stuff, and the function is generally written under the symbol. So the square root function is normally written like this, where x could be anything. And the square root symbol is that sign. Now it says whenever you are presented with the square root function, first we write the function raised to the half power. That is x raised to the half. Recall, the nth root of a is going to be equal to a to the 1 over n. So we call this the nth root of a. It's the nth root of a, and I don't understand how that's something you're going. I don't want to respect the general. No, another one. Undo. Right. It is called the nth root of a. Now, work with me. Inside here, let me bigify this thing here. Because Sasha's going to say, sir, I'm in the trunk and I can't see it well. So now that I've bigified it, where you see this N, this is called the sleeve of the square root.
Sir, I'm not in the trunk. I just reached home, sir.
I'm happy. This N is in the sleeve of the square root sign. It's in the sleeve of the square root sign. And whatsoever number that is in the sleeve of the square root sign is going to be reciprocated and becomes the power. So this n is really a number that can be written as a rational number. Any number can be written as a rational number by dividing it by 1. All right? So if you're given a whole number and they ask you to write the whole number as a rational number, so what do you mean by rational? A fraction. Rational from the word ratio to share, yeah, having a pizza, craving Ryan by 16 slice pizza, me happy, Mr. Bridget, big a couple slices now. Mr. Shannon, hold this, 2, and in eat of 14, so it's a 2 to 14 ratio. So I got 2 slices, he has 14 slices, all right? So the word ratio, rational, they relate. This n is in the sleeve of the square root sign. When I reciprocate it, it becomes the power. So, sir, that means that this n is n over 1? Absolutely. N over 1. When I flip it, I get 1 over n. See it right up here, so? So anything that is under the square root sign is going to be written as the base. And whatsoever is in the sleeve of the square root sign will be reciprocated and is written in the power. Blow, that's so nice, see? Yeah, that. We should have read that in Jesus. When I say a while ago, all right, me listen to the recording. That one is so nice. Similarly, the nth root of a to the m, the nth root of a to the m relates to this one. The difference with this one and this one is that whatsoever is under the square root sign is written to the first power. But this one here can be written to any power. So this is the nth root of a to the m. The nth root of a to the m is going to be Remember I said to you, whatsoever is written under the square root sign is going to be this as the base, and then what is in the sleeve of the square root sign is going to be reciprocated and become the power. So watch me. This is a to the m. I'm putting it in parentheses because it comes as a package. The n is in the sleeve of the square root sign. I'm reciprocating it. So instead of n over 1, it becomes 1 over n. See it here. So a base raised to a power, which in turn is raised to another power. I'm going to be multiplying both powers. That's one of the laws of indices. So a base raised to a power, which in turn is raised to another power. The law says we are going to be multiplying the powers. We are going to be multiplying the exponents. We are going to be multiplying the indices. So when I multiply m by 1 over n, I'm going to get m over n. So the nth root of a to the m works out to be a to the m over n. Oh, sir, I see something. I see it, sir. Maybe because I put it in blue, why I seen it. What is in the sleeve of the square root sign is going to be in the denominator of the power. Jesus is true. See it here again? Yeah, that's what it is. So please note, whatsoever is in the sleeve of the square root sign will be replaced as a reciprocal power. All right? So it means I'm again reciprocate it and put it as a power. All right. So that's just me explaining what the square root sign is and how it is that we can maneuver and play around with the square root sign. All right. Now, in addition to this, no, not in addition to this, what we're going to be doing now is to look at some questions. So it says to differentiate the following functions. Now remember, whenever you're presented with the square root sign function, first rewrite the function raised to the half power. The square root sign, I should tell you, this n can be any number. I may normally use whole numbers for this course. We normally use whole numbers for this course. If this n is a 2, we're not going to write the 2 in here. Square root square. When you square something, what you get? What do you do in order to square something? What number comes out to you? What number?
It comes by itself, sir.
Yeah, so that means I'm going to do it how many times?
2 times.
2 times. Very good. So this n, if the value of n is 2, do not write it in the sleeve of the square root sign. Leave it blank. Why, sir? Because it is understood that there is an imaginary 2 inside there. Then, sir, what if it's a 3? Then we'll write the 3. What if it's a 4? Then we'll write the 4. What if it's a 1? We don't need to write no 1. What if it's a 2? We don't write the 2 neither. All right? So look at this. Before we look at this, so why we don't write it? Because it's redundant. It's like me coming to you and say, can you repeat that again for me, please? Or I would say to you, the rain is falling. That's the only thing the rain can do. Fall. All right? So so I'm teaching you the jargon. So once it's a 2, if you don't say a number in it like this one here, sir, I'm not seeing a number there. We assume that it's a 2. We know it's a 2. So in our headspace, we know it's 2. And when we reciprocate 2, we can get 1/2. That's how we get this 1/2 right here. So that's how we get this 1/2 right here. So, all right. Now, so I'm giving a recall for differentiation. Y is equals to x to the n. Therefore, dy by dx is going to be n x to the n minus 1. And let me just pause right here, because I have to say this at this point in time. I cannot believe I would sit down night after night I remember the first class I said to you guys, based on the number of hours to complete the course, we're going to need an extra hour. Can you do up to 10? G's on P, sir, 10 o'clock? And guess what? To be honest with you, I am sure if I'm going to stop class at 9 o'clock, we said, no, sir, we're not going to go for it because it has become so much a part of you that I won't know. For me, it's neither here nor there. I cannot believe that we spend 5 quality hours per week. And I would give an instruction to say, differentiate from first principles. From first principles. And I have this on paper presented to me to mark when I said first principles. How many marks do you think the person got for this one?
0.
0. 0. So, which is why I just need to do a little talk, because you have to follow my instructions. Follow my instructions. When the man them say first principles, forget about everything else. The man them want first principle. All if the answer right, you're not going to get a mark right because you did not follow the procedure. You have to follow the procedure, guys. Come on, man. I've said this like a gazillion times in class. Follow my procedure, man, please. All right, moving back to this. So, y is equals to x to the n. So therefore, dy by dx is going to be this n, x to the n minus 1. Everybody knows this. I know everybody in this class can differentiate. Watch me now. Whenever you are presented with the square root sign function, first rewrite the function raised to the half power. Oh, this is the square root sign function. I'm rewriting the function raised to the half power. Got it, sir? Then I'm going to differentiate this. Oh, so that this looks like this then, sir? Yes. So dy by dx is going to be equal to this half. It was in front. See it right here, so x to the n minus 1. A half minus 1 is minus a half. Differentiation done right there. But I want you to note something. Note a to the negative m can be written as 1 over a to the positive m. We always reciprocate to obtain a positive result. We never normally leave our answer as a negative reciprocal. We never normally leave our answer as a negative value here. All right? So we reciprocate it so that we can leave our answer as being positive. Then, sir, suppose a question asks you to leave your answer that's fine. Am I wrong? No, you're not wrong. But generally, we leave our answer in this format. Watch me now. Watch me. I'm going to write this as a positive power. Don't want a negative power. You see this half? See it right here, sir. This 1 over 2 are the same thing right here, sir. Because I have a to the negative a half, a to the negative n is equal to 1 over a to the positive n. Or this is going to be 1 over x to the positive a half, sir. See it right here, sir. 1 over x to the positive a half. So it now becomes, watch it, the 1 over 1, the 1 over 2 times the 1 over x to the half. This is not a full stop. Big school multiplication sign. 1 times 1 is 1. 2 times x to the half is 2x to the half. But x to the half is the same thing as the root of x. So I can write this x to the half as a root of x. And then this now becomes my final answer. Then so we have to rewrite it as the root of x. Remember, that's the form they gave us in. So we put it back in the form that they gave us in. All right? Any questions so far? I'm going to do another example. Any questions so far? Okay. Lord Jesus, we didn't know, you know. We didn't know. We saw him come and present something with just X under something. It's just a matter of time for we say, voting for something under something. It's not a problem. Fret not. Don't even get concerned about it. Watch me. y is equal to the root of 2x plus 3. Anything under the square root sign, raise it to the 1/2 power. Then, sir, suppose we have 3 inside of the sleeve, you'd have raised it to the 1/3 power. And 5, 1/5 power. And 100, 1/100th power. And a million, 1/1,000,000th power. Oh, so you're saying that when you're not seeing a number in here, you can raise it to the 1/2 power. Two. So I'm going to convert this. I'm going to let y be equal to this. This is a nicer form for me to differentiate. dy by dx is going to be this 1/2. Bam, see it here so. I arrive at my function, see it right here so. This is going to be 1/2 minus 1, which is a negative 1/2. Bam! But I must now differentiate on the inside here so. And the differential of 2x plus 3 is 2. Can somebody remind me of this rule?
The power rule, sir.
Thank you very much, John.
Sir, it's not Yanni.
Sorry, I'm Shani.
Sir, look a bit and shake up your brain, you know, sir. You need to not malice us again to mark the paper.
You just make sure you remember you say that to me here. All right. Recall. I have nothing more to say to you, Miss John. Thanks here, Charlene. Recall the POWERRULE, the power rule. Very good, Charlene. Have pretty sure eye. All right. Now, so when I use my power rule, remember, Sash, was it you who always don't remember that you need to differentiate the inside? No, it's not Sash. It's just a business calculus student who always forget.
Jesus, here you know.
Yeah, man. You know, Sash, me know, man. So me just want you to do very well. So that's why. But remember, guys, we have to differentiate what is inside the parentheses. You have to differentiate what is inside the parentheses. So this times 2 comes from the differential inside here. So then the differentiation done right here. So you know what I'm going to do? I'm going to put this in blue to show you that this is my partial answer. All right, watch me now. The 2 here times 1/2 makes a whole. And that's 1 is in front here. So this 1/2 cancels out with this 2. So all I'm left with is 2x plus 3 raised to the 1/2 power, negative 1/2 power. And because I don't like my answer to be written as a negative power, I'm going to reciprocate it. So this becomes 1 over 2x plus 3 to the positive 1/2, which is this. And anything raised to the 1/2 power can be written as a square root. So I'm going to put 1 over the square root of 2x plus 3. The question is finished. Really, actually not difficult. Go ahead, please.
Sir, my last right after you talk about the
this one here?
Differentiation inside.
All right. Yeah. So do you understand what is in blue?
Yes, sir.
Watch me now. This 2 times 1/2 gives a whole. This 1/2 times this 2 gives me this 1. So technically it cancels it out. This 1/2 cancels out with this 2. This 2 cancels out with this 1/2. Then I'm going to be left with 2x plus 3 raised to the negative 1/2. This is all I'm left with. See it yourself? 2x plus 3 raised to the negative 1/2. But we never normally write our answer as a negative power. So I'm going to reciprocate this to get me 1 over 2x plus 3 to the positive 1/2. So why I'm doing this is to change this negative here to positive. So it becomes a positive here. And then, as my final answer, anything raised to the 1/2 power can be written as a square root. We just did that. So I'm going to have 1 over the square root of 2x plus 3. Jesus, Father. Oh, sir, see so. What rule do you think we're going What rule do you think we're going to use right here, so?
The product rule, sir.
The product rule. You see what I want to do? I'm doing this because I want to make sure I teach you everything so that when you go into the exam, you at least get an idea to see what is happening. Now, granted, you will go into the exam and see something that, chances are you'll go into the exam and see something that, how do I do this? Oh, but then again, no, sir, they teach you this, you know. Oh, this you have to go use to do it, right? So remember, I'm not teaching you how to answer questions. I'm teaching you concepts. So it is for you now to use those concepts to concretize your understanding of the concept that I'm trying to bring across. Let's go. Don't worry about how ugly this looks. You know the product rule. You know now how to differentiate using the square root function. We're just going to follow the procedure. It does not matter how ugly it looks. The truth of the matter is, let us just follow the rule. What does the product rule says? The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Name it. Name it first and name it second. No worry about it. We're going to follow the procedure. And I'm going to highlight the procedure, the process for you.
One moment, sir. Auto turn off your camera, please.
Cool. So we are going to follow the procedure. What is the procedure saying? We identify our first, we identify our second. But sir, you know, see the square root saying, remember the first thing you're going to do when we get the square root, we're going to convert it. We don't see no number inside of the something, so we're going to write x squared minus 1 raised to the 1/2 power. See this up? X squared minus 1 raised to the 1/2 power. So we're rewriting our question to how sir so we're supposed to rewrite it. Please to pay attention to this. I don't ready to call names yet. Pay attention and don't do your own stuff. You do your own stuff, you're going to be penalized. Sir says, when you have the square root sign, you're going to convert it and write it raised to the 1/2 power. So this line is exactly the same line up top. The only thing that I did was to name my first and to name my second. Now, watch it. The first, see here, times the differentiation of the second. I'm differentiating the second. Watch it. This is a half in front, see it here. The x squared minus 1 is written back. It's a half minus 1, which is minus a half, see it here. But I have to use the power rules, I have to differentiate on the inside here. So when I differentiate negative 1, I get 0. But when I differentiate x squared, I get 2x. See it here? Times 2x. It's done. None of you can say that this is strange and difficult. But because some of you may have taken your eyes off the screen, or some of you may have blinked, I want you to just look now. No blinking. The first, I write it back, times, see here, the dot, the differentiation of the second. When I differentiate this power, I'm going to get this 1/2 in front of. X squared minus 1 is written back, and this 1/2 minus 1 gives me a negative 1/2. Then I must differentiate what is on the inside of the parentheses. Differentiation of this constant is 0. The differentiation of x squared is going to be 2x times 2x. Right here. Plus the second. See the second here? I'm writing back all of this. See here? X squared minus 1 to the 1/2 power. Times the differentiation of the first. When I differentiate the first, this 5 times this 2 to give me 10. X, 5 minus 1, 4. 10x to the 4th. See here, so? Times 10x to the 4th. Differentiation ends right there, so. Differentiation ends right there, so. All I'm going to be doing now is fixing up the food cook. But just I got dish it out and garnish it. You understand? Yeah, watch me now. This 2 times this 2 gives me 4. 4 times a half gives me how much number?
2, sir.
See it right here, sir? That's why I get this 2 right here. I refuse to write another line. You're at calculus 1, suppose you can see it. Another way of looking at it is 2 times a half is 1. 1 times 2 is 2. X to the 5th power times this X. I can't touch this X, you know why? This negative 1/2 guard it for life. I cannot touch this 1/2. I mean, this X squared minus 1, because this negative 1/2, the power guards it for life. So it's this X to the 5th times this X to give me X to the 6th. So that means I know get rid of this, I get rid of this, and I get rid of this. I'll just write back this. X squared minus 1 to the negative 1/2. See here? X squared minus 1 to the negative 1/2. Then I put back the plus sign here, so right here, so. And then no, I don't have anything to multiply that, so I'm just going to carry the 10x to the 4th in front. See it right here, so. And this x squared minus 1 to the positive 1/2 right here, so. I said something to you some time ago. See it here, so. Always factor out the smaller of the two every single time. Do you recognize that x squared minus 1 to the negative 1/2 and x squared minus 1 to the positive 1/2, that there's something common to the two that we can factor out? Say yes.
Yes, sir.
Which is the smaller of the two?
The half.
Very good. No, which of them?
Negative 1/2.
The negative 1/2. The negative 1/2 is smaller. So always look for the smaller of the two and take it out. Okay, sir. So that's how you get this x squared minus 1 to the negative 1/2, because that's the smaller of the two. Yes. But sir, why you get 2x to the 4? Thanks for asking. What is common between 2 and 10?
2.
And that's why I get this 2. What is common between x to the 6th power and x to the 4th power?
X to the 4th power.
Why? Because I am taking out the smaller of the two. I can't factor out x to the 6 because we end up with a negative sign, and we don't want a negative sign. Remember, I tell you that we math people are positive thinking people. So we see the glass as being half full rather than being half empty. So we have to take out the smaller of the two every single time. Every single time, smaller of the two. So that's why I get the x to the 4th, because x to the 4th is smaller than x to the 6th. Now, all of this will be my factor term. Watch me. My factor term, all of this, are the same thing like this, are the same thing like this. I'm factoring it out. All of this, all of this. Then, sir, why is not the same thing as this? I'm going to show you, because we do a conversion down here, so that's why. So once you factor it out, you can carry it all the way down until you finish. Sort out this. Okay, sir, let's go and sort out. What do I multiply by 2x to the 4th to give me 2x to the 6th?
X squared.
See here, so? X squared. So x squared times 2x to the 4th gives me 2x to the 6th. Got you, sir. Oh, and this, sir, is the same thing as this. So you just multiply this x squared by 1. But we don't have to put the 1, sir, so we can just put the plus sign. Very good. What do I multiply by? 2x to the 4th to give me 10x to the 4th.
5.
5. That's why this 5 is here. 5 times 2 is 10, and the x to the 4th go up here, so. Watch this magic. Don't blink. You may lose it. What do I multiply by x squared minus 1 to the negative 1/2 to give me x squared minus 1 to the positive a half. Sir, I know, sir. The law says when you're multiplying and the bases are the same, you're going to add the powers. So the base is going to be x squared minus 1. So all you need to do is to add the powers. So in order for me to get a positive a half, it means that I need to add it to a 1. Negative a half plus 1 gives me a positive a half. So that means this x squared minus 1 has now to be raised to a positive number or a whole number 1. Let me go again. When I multiply x squared minus 1 to the negative a half, and I multiply that by x squared minus 1 to the positive a half, the rule says a to the m multiplied by a to the n is going to be equal to a to the m plus n. Mary plus Nancy. Apple raised to Mary multiplied by apple raised to Nancy is going to be equal to apple raised to Mary plus Nancy. A to the m multiplied by a to the n is going to be equal to a to the m plus n. And that's one of the laws of exponents. One of the laws of exponents. All right? Watch me now. So that's why this negative a half, in order for me to get this positive 1/2, it means that I must add 1 to this to get this positive. And this is why this 1 is here. Now, when my parentheses is being raised to the first power, I can drop it. And then I can do anything to get on the inside now. The only way I can drop these parentheses is unless this power is raised to 1. If it's raised to 1/2, negative 1/2, I can't do it. It must always have to be 1. Watch me. 5 times x squared is 5x squared. 5 times negative 1 is negative 5. So I can group all of what is inside here now. And so 1x squared plus 5x squared is 6x squared. Then, sir, we not talk about this. So we don't establish that this is the same thing as this. It could be the same thing as this. 5x squared plus 1x squared is 6x squared. The minus 5 stands alone, so I carry it back. Now watch me. Watch me. This 2x to the 4th is this. This 6x squared minus 5 is this. Sure, where is there? Remember, this is raised to the negative 1/2 power. So again, drop it in the denominator now for it to become to the positive 1/2 power. See there? X squared minus 1 raised to the negative 1/2 power. In the denominator, it now becomes x squared minus 1 to the positive 1/2 power. And remember, anything that is raised to the 1/2 power can be reconverted to the square root. So all of the numerator is all of this numerator. Same numerator here is the same numerator here. I just convert this x squared minus 1 to the 1/2 to the root of x squared minus 1. All right? So this was a mouthful. It really isn't difficult. For those of you who are not so clear just yet, just understand that you've just learned it. It's now 10 past. I'm going to give you that easy one to do for me. But I want to be able to project the whole question so at least you can see.
A question, sir.
Go ahead, please, son.
I don't know if I don't know. I missed it.
Mm-hmm.
You have the first times the differentiation of the second, right?
Mm-hmm.
Sir, bigify it, please.
You want to bigify it, all right.
Yeah.
Mm.
Yeah. Right? First times the differentiation of the second plus the second.
Mm-hmm.
All right, never mind. Me see it now.
You see? Let me just put it out. Let me just put it out there. Is friendship friending me up, you know, because you know I'm upset with her. Is friendship friending me up because you know I'm upset with her. And it's a good upset, you know. It's a good upset, you know. But yes, sir. Go ahead. Finish.
Well, I need okay, within the blue section here. Remind me, what happened to the half, the positive half?
This right here. Oh,
yes.
Which one? This
yes,
one
the same one here.
The one here?
The same one.
Magic. 2 halves make a whole times 2 is 2. So this 2 times this 1/2 times this 2 gives me 2. 2 times 1/2 is 1, and 1 times 2 is 2. X to the 5th times x gives me x to the 6th. And then all of this is written back right here.
All right, copy that.
Nice. All right, now.
Sir, for the 5, where you divide 2 for the second line after the recall, always factor out the smallest of the 2.
So I'm saying, how many times can 2x to the 4th go into 10x to the 4th?
So 5 into
So, sir.
I'll come into you, honey. Just hold that question for me, please. So what I'm saying to you is 10x to the 4th divided by 2x to the 4th. This goes into this 5 times, and the x to the 4th cancels, so it's going to be 5. And that's why I have the 5. Where? Right here. So I have the 5 right here. So what I'm asking myself is, how many times can this 2x to the 4th go into 2x to the 6? Watch this now. 2x to the 6 over 2x to the 4th. The 2's cancel. All of this go into that and leave 2, so it goes into x squared times. And that's why I have the x squared right here. So I don't need that gives a better understanding or explanation. Go ahead with the other question, please.
Sir, that means whatever you have in the square root always supposed to end up back in the denominator of your differential.
Most times. Most times. Most times. Sometimes you get some functions that will end up doing some cancellation. It depends on the function that you can cancel some things. But most times, yes, it ends up back in the denominator. Because if you end up with a x to the negative 1/2 outside here, so most times you can have it. Not all the times, you know. But most times. No, some should have. Okay, yeah. I can't do it. When I said bigger stuff, I was just showing you something else. Yeah. All right. I want you to try this for me. Hold on. All right. Let me work with you with this one. I will generate some questions for you before I send out the document. So this one looks a little easier than what it is that we did up here. But it's the same procedure. Trust me. You can call one a first, you can call one a second. We already established that we can call any one of them a first and any one of them a second. But sir always try to be consistent and call the first one the first and the second one the second. All right? Remember, sir also says, whenever you get the square root something, convert it and write it to the 1/2 power. Once it is that you're not seeing a number inside here, you're going to assume 2. Look out to the question because the man they must say 7x, the cube root of 3x squares. And if you raise it to the 1/2, you're wrong. Because any number in Yasso must be reciprocated and placed in Yasso. But if you're not seeing a number in Yasso, you're going to assume numero dos, number 2.
Sir.
So that's why it's 2 here, 1/2 rather. Go ahead.
So whatever they have, so let's say they have it 4th. So it's going to be 1/4.
Very good.
Okay.
Very good. It's only when you're not seeing a number inside here, so you're going to raise it to the 1/2 because we know that this originally comes with a 2. Can't change. So if you're not seeing a 2 inside here, so if you're not seeing a number inside here, so you're going to assume 2. But if you see a number other than 2 right here, so no, don't be bright enough and put it over 1 over 2. Any number in your so will be reciprocated and placed right here, so. Just remember that. That's our first line. I can't overemphasize that point, right? And I don't want to overkill it. Then we're differentiating. Of course, it's a product. It's the first times the differentiation of the second plus the second times the differentiation of the first. Incidentally, let me just put a plug right here. For those of you who think that I'm finished with differentiation, I'm sorry to disappoint you. For the rest of the course, I'll be going through differentiation. What I should start on Thursday, all being well, is what we call integration. Is what we call integration. All right? So now, the first times the differentiation of the second plus the second times the differentiation of the first. When I call the first, I write it back the first. Bam. Times the differentiation of the second. Oh Lord, power rule. Okay, power rule says you carry that in front of the something, you write back the parentheses, you reduce it by 1, and then differentiate the parentheses. Remember, a 3 something, you carry back in front, you write it back, reduce it by 1, and differentiate what is inside. Let's go. This, you carry it in front, see it right here, so. Number 1. Number 2, you write this back, see it right here, so. Then you're going to write it back and reduce it by 1. A half minus 1 is minus a half. And then the third step is to differentiate on the inside. The differential of this is going to be 6x. See it right here, so. Done. Let's go again. 3 steps. Power rule, 3 steps. Power rule, 3 steps. I'm taking this to drop in front of this. Bam. Step 2 is that I'm going to, hold on a minute, please.
Type it.
Sorry about that breaking transmission. So 3 steps. Step number 1, this half is going to go in front. See it here, so. Step 2, you're going to write back this inside the parentheses and reduce it by 1, the power by 1. See it here, step 2. Step 3 is to differentiate on the inside of the parentheses, and the differential of 3x squares is going to be 6x. It's done. Then again, say plus the second. You're going to write back the second 3x squares to the 1/2 power, see here, so. And then you're going to differentiate the first. Differentiating 7x, I'm going to get 7. The differentiation, my friends. Oh, come on. Let's move up this tonight. It's not good at the teacher. The differentiation ends right there. We now need to fix it up. And sir, if the differentiation ends right there, I can just stop right here, sir. If you want to try it, you're going to lose the mark. Because a part of the problem is when you get into your area of specificity and you do the work, you can't just open up the computer and just leave it and say, all right, I'm going to lock it up. Problem solved. Problem solved for 3 now. But you have to do the networking and put the something neatly and clip up all of the supplement and tie back the supplement, let the station be nice. Same way, so we're going to nice it up. Watch me, don't blink. 7 times 6 is 42. And a half of 42 is 21. Let me do it another way. A half times 6 is 3. And 3 times 7 is 21. 7 times 6 is 42. 42 times a half is 21. Or a half times 6 is 3. And 3 times 7 is 21. Whichever way I do, take it the same something. A half times 7 is 7 over 2. 7 over 2 times 6 is 42 over 2, which is 21. This x times this x gives me this x squared. Then, sir, you're not going to multiply by this 7. No, that's something I break it. This barge, break it. I cannot step over this territory. I have to stay in this region of the game. So the x here, multiply by the x here, give me the x squared. And then I'm writing everything right here. See it right here, sir? Bam. The barge. Barrier. I write it back. And I have nothing to multiply this to really cancel out the 7. So I just put it in front of the something to make it just nice it up. 7 times 3x raised to the half. Always factor out the smaller of the two. Every single time you will factor out the smaller of the two. Always factor out the smaller of the two. You can't factor out one big number. Normally when I teach foundation concept, when I speak about factors and multiples, factors and multiples. What is a factor? The smaller into the bigger. What is a multiple? The bigger into the smaller. We're not talking about multiple, we're talking about factor. So once you're factoring, it has to be small into big. All right, let's go. So now, I'm factoring out the smaller of the two. 3x squared to the half compared to 3x squared to the negative a half. Which is smaller?
The one with the negative a half, sir.
I think so too. I think so too. So that's why I factor out the one with the negative a half. That's why I'm going to do that. And then now, I ask myself the question. What is common between 21x squared and 7? I'm going to say, but no 7, sir, because you know, have an x right here, so a 7. Absolutely. Is there anything else that is common? No. Because this is how sir normally do it. I go with the ugly looking something first to take out, and then I take out, the ugly looking something to take out first, and then I do the other ones after. 2 times a half is 1 times 2 is 2. X to the 5th times this x gives me x to the 6th power. All right? So let's go. Now, when I do that, I'm going to end up now factoring out the 3x squared, my 3x squared raised to the negative 1/2 power. Bam. And I factor out my 7. I know there is nothing else to factor out. You see, once I say nothing else to factor out, then you're going to work it. What I multiply by 7 to give me 21x cubed has to be 3x squares. So that's why I have the 3x squares right here. I've got to know, sir. And because this term is exactly the same as this term, it means that it is multiplied by 1. So that is it. So when you multiply all of this here by the 3x squared, 3x squared times 7 is 21x squared times 3x squared to the negative 1/2. See here? You get back the term here, so. And then now, 7 into 7 goes 1 time, so I have 1 right there, so. And this here now is 3x squared times 1/2 times negative 1/2 power. And we want a positive 1/2 power. That means the one have to be 1. So how you do that again? Thanks for asking. Remember what I did right up here, so? 2x to the 6. And I'm asking 2x to the 6, and I'm saying how many times can x to the 4 go in there? So it's this divided by this to give me the x squared. Watch me here, so. If I can find my implementer right, where are you? Watch me here, so now. Ah. Watch me here soon. Where am I? Okay, so I'm going to say 3x squares raised to the 1/2 power divided by this one here, 3x squares raised to the -1/2 power. Recall, you know, let me take off you, because you're just a slope like something, you know. And there's no slowness to what it is that we do around here. Recall, a to the m over a to the n is equal to a to the m minus n. So it's the numerator power minus the denominator power. So it's going to be 3x squared to the 1/2 minus a minus 1/2, which gives me, when I multiply these two, it is converted to what? It's a positive. Hello, somebody.
Positive.
Yeah, man, thank you, please. So I'm going to end up now with 3x squared to the 1/2 plus 1/2, which gives me 3x squares to the first power. See that here, so.
Sir, that look like sperm.
Oh Lord. You know, why I laugh out loud? Because when I drew it, I had the same thought. I was like, oh Lord, what am I doing? All right. Pretty teacher here. All right, let's go. So all right, so yes. So it gives birth, no pun intended, to this new term, which is 3x squared to the first power. And then what we're going to have right here now is, because this is raised to the first power, I can remove my parentheses. The only time I'm able to remove my parentheses is when the something is raised to the first power. Any other power that it is raised to, me can't remove it. The only time I can remove my parentheses is when it is raised to the first power. Any other power, I am not allowed to do it. Okay. The only time I'm allowed to remove my parentheses is when it's being raised to the first power. When it's being raised to the first power. That's the only time. Every other time, it does not work. It doesn't work. All right? So when I remove it now, what I'm going to have is 3x squared plus 3x squared. Blah, blah, no 6x squared. That. And I'm going to have my 6x squared right here. And this piece is 3x to the -1/2. So I'm going to put it in the denominator and cause it to become a positive 1/2. Right? And then this, of course, can be written as the root of that. Now, when I say bigger stuff, you know, should I even go here? Yeah. When I say bigger stuff, I can rewrite my function. I can rewrite my function in the form. Give me half a second, please. So this root of 3x squared is me able to write it as a root of 3 times the root of x squared. So when I have the root of 3x squared, it's just rewriting the root of 3 times root of x squared. And when I find the root of x squared, I'm going to just get x. So I call it x root 3. And then this x cancels with one of the x's here. So we have 42x over the root of 3. And yeah, it's just a little bigger stuff. So to be honest with you, I think for the calculus one, they will end right here. I don't think they will go all the way down to here. Yeah, let me think through this a little bit more, and then yeah, and then do that. All right, that ends the square root function.
The graph. Sorry, just you were saying that you were gonna show some graph on the first topic that we did, the limit.
Yeah, man, I remember all too well. I remember. Don't think that I forget. I remember at the start of the class, I was saying to you that I'm finishing off differentiation and then I have some granular stuff to work on. I don't know if anybody heard when I said that. Anybody remember me saying that?
Can't recall, sir.
You can't recall.
Something like that.
Right. I did say that I have some granular stuff to look at and I will do it. Yeah, those are one of the stuff. I found a software. Matter of fact, at the end of the class, I can give you the name of the software. So it is that, no, I'm not being confused because I'm doing this already. So I found a free software, not found, I mean, I've always used it. I'm going to give you an open source software so that you can download the stuff, but I want to show you how to do the sketches first, the piecewise function first, because it was on piecewise that I wanted to show you the stuff. So when I do the piecewise function, teach you how to sketch a graph piecewise, I am going to then introduce the software that you can just download on your phone, and then you're going to sketch the graph, put the information in, sketch the graph, and then you can compare the graph that you've drawn versus the graph that you have done the stuff. I don't want to show you the function first, I mean the software first, because people are not going to want to learn how to sketch a graph. So far, I'm very confident that you are learning, and I want to keep it in that mode. So that's why I don't show it. But trust me, that is like a 15 minutes, if so long, lesson. Don't worry about it. I remember. I have a notation of it in my stuff, and I remember. Thanks, though, for the reminder. All right, so I have about half an hour left. And I just want to use this time just to help clear your mindset from the differentiation that we just did of the square root function. And
Sir,
just to say,
you're going to send the recording, right? Because that's how me go through them.
I always do.
Okay.
I always do. So where was I? So in summary, you will recognize that when we are differentiating the square root function, it is performed in a similar manner when we're using the chain rule, we're using the product rule, and we're using the quotient rule. But sir, we never use the quotient rule a while ago, because I don't give you any of the questions to differentiate using the quotient yet. I can give you the chain rule, square root function in it. I can give you the product rule with the square root function in it. I could also give you the quotient rule with the function in it. The point I was bringing across. Let me just do something here. I really don't understand what is happening.
It says read only, sir. It says read only.
No, right, but I mean, I should be able to still interface with it, and then I can save it after, because I have been doing some stuff. See, I'm writing in it. Okay, it just come up now. I don't understand what is happening.
Sir?
Yes, sir.
All right, you can scroll up from please. I want to ask a question.
I just need to put this as my reminder. So when I'm going through the document, you want me to scroll up?
Yes, yes.
Yes, sir.
Right at, where is it? All right, go up to the one before this, question before this. Oh, no, leave it where it is. Okay, right here in the blue section, right? Has there ever been a situation in which you have to times the half by a number that is not?
Yes, Kemish. What you're saying to me, sir, we can't ever do this something and get a fraction in other something? Yes, Kemish. Yes.
Cameron, sir. Cameron.
Andrew. Sorry, Andrew. Yes, Andrew. Sorry. Yeah, man. Oh Lord. You know.
So
yeah,
in a
yes,
situation
Andrew.
like that, how yeah, I want to know.
But Andrew, you notice what I did, you know, Andrew. Remember what I said, you know, because I was anticipating this question before. I said to you, 7 times 1/2 is 7/2. You remember when I said that? Anybody remember when I said 7/2?
Yes, sir.
Yes, sir.
Right. And then when I said 7/2 times 6, I'm going to say, I did say 42/2, which is 21. So what I'm saying to you, Andrew C, is when you differentiate on the inside here, the function could have been 3x cubed. And 3 times 3 is 9. Rockstone. 9 times 7 is 63. Blow. 63 times 1/2 is going to be 63/2. So yes, Andrew C, you can get something where it's not going to be a whole number right here. It's going to be fractional. Yes. And let me tell you why, Andrew. And I appreciate that question. Let me see if I can go up. I think it's in this document. Let me tell you why I appreciate that question. Oh, I just passed it. When we were working the past papers the other day, I found 2 questions in the past paper. You see how them give you something looking very ugly right here, sir? It's very ugly, no? I would be the first to admit that this question is very ugly. Is it solvable? Absolutely. We know how to do it. We know this is a product. X squared is being multiplied by ln, all of this. We know that. So we can do it. The first times the second plus the second times the first. We know how to do this, right? So I'm saying to you, because I know students don't like fractional stuff, they will include a fraction part in their paper. Real talk.
Sir, so you have to do it too?
No, man, I want to set the question, you know. Remember, I don't know what the differentiation, the function that they will give you to differentiate, you know. I know I've taught you differentiation, but I want to give you as many of the variations that they could possibly give so that when you go into the exam and see it, you don't have to worry yourself. So I have not done one where the question, the final answer is going to be in the fractional form. Well, actually, I have the first one. The first one was in the fractional form. The first one was in the fractional form where I had a 1/2. Right here, so no, not there, so I said first. Yeah, where I got the 1/2. See here, Andrew, where I had, when I did my multiplication, I ended up with a fraction, and I never had anything to work with the fraction. You see this 2 now ends up in the denominator. Right here, so and AC, you see it?
Yeah, I see it.
Right. So it's something like that I'm talking about. But as I said before, don't worry about it. Sir has a replete number of questions. Today I was going through some more papers and I stopped and I just started writing some questions on this one that we're moving to now, and you know, don't worry about it. I will definitely do that. But thank you for the question though. What it does for me is to give me, you know, some ideas to include some additional questions that I may not have, so that we can do our stuff. So yeah. So thanks to Andrew students, you'll get questions including the fractional form. All right. Even one question on my implicit differentiation, I must do. We have 20 minutes. We have 20 minutes. We have 20 minutes. Implicit differentiation. So when we're doing our implicit differentiation, as the question suggests here, if x squared plus 3xy plus y squared is equal to 16, I need to find dy by dx. Now you recognize that this here is now, I don't want to call it a multivariable function, but it is a function involving both x and y, as opposed to the other questions where you got y to be equal to something. Y, the dependent variable, was equals to x, the independent variable. But now, everything is together. There's no independent variable here. There is no dependent variable. So what you call independent and dependent variable is a term that you should know from little school. Let me go to my y equals x to the n. My y equals x to the n. My y is the dependent variable. My x is the independent variable. Whatever the value of, so the y depends on whatever the value of x is. Whatever the value of x is, y depends on. X has a mind of its own. X can choose anything that x wants to choose. And then y now becomes that value. So if x wants to be 5 over here, so that means y is 5. If x decides to be 2, y is going to be 2 because x is equals to y, or y equals x. All right? It reminds me so much of life. The woman always gets what she wants. Do not buy another pair of shoes. Okay, sure. But she passes the store and sees a killer shoe. And she said, well, guess what? I'm not gonna know. But God has a sense of humor that she takes out the other credit card and swipes. And then you get a notification, $15,250 at collectibles. And you look and say, what? And you say nothing to the wife until she buys a new pair of shoes. And then say, oh, that was a $15,000 pair of shoes about the other day? Yeah, man. So one is independent, one is dependent. So this x is my independent variable. The y is my dependent variable. Watch me. In this case, none is depending on the other. They mix up together. So husband working money, wife work for money. Wife can't tell husband how to spend money, and husband can't tell wife because they work them own a door. They know how to spend their money. Watch me.
Men in the class, take notes. Okay.
Real talk. You know, a side note, I have a good friend who was livid at his wife. And I said, brethren, get over it. Get over it. He said, you wouldn't understand. I said, what is so difficult? What is it that she could have possibly done to get you to be this upset? What? And he says, she went away and she bought a blouse for $4,000. I said, 4,000 Jamaican dollars? And the person says, she went away and bought a blouse. I said, 4,000 Jamaican dollars? Away mean like Ocherios? She went to foreign and bought a blouse for $4,000. And I never want to tell the brethren to flip. But as I know, I would have flipped. You understand? $4,000 US on one piece of garment? Negative.
Sir, it's a celebrity.
Sir, you're not supposed to be upset. It's Louis Vuitton.
Ah! Guess what? Anyway, I couldn't be a teacher under that. So maybe that's why them people are in them kind of jobs. But anyhow, let's go. So watch me with the differentiation now. This is big school stuff, you know. Big school stuff. Watch me. So
sir,
every time I
bigify for me, quick and fast.
Yeah, man, quick and fast. Bigify. Me know such Shana spectacles and See, all right, so she's supposed to can see this now. No, watch me. You see my dependent variable? Every time I differentiate my dependent variable, I'm going to get dy by dx. What is my dependent variable against her? Y. Every time I differentiate the y, I'm going to get dy by dx. But when I differentiate the independent variable, it stands alone. Watch me. The differential of x squared is 2x. Bam, done. The x don't have to ask nobody no question. It done. The next one, blow, sir, this is like 3x times y. Sir, the mere fact that I said times, it sounds like it is the product rule. Yes, you're correct. Watch it. The 3x is the first, see it here, so, times the differentiation of the second. When I differentiate y, I'm going to get 1. But the independent variable I have to find, dy by dx. So it's 1 times dy by dx. Plus the second, plus the y, see it right here, so, times the differentiation of the first. When I differentiate 3x, I'm going to get 3. It done. Remember, the product rule says the first, bam, times the differentiation of the second. When I differentiate y, I'm going to get 1, but then we also have dy by dx.
Sir, draw breaks.
Okay.
Rewind and come again.
Rewind and come again. All right. So my independent variable, my x, when I'm differentiating it, when it stands alone, it's good to go. But when I'm differentiating my dependent variable y, every time I differentiate y, I'm going to differentiate y, you know. But it's after I differentiate y, I have to write dy by dx. Let me say it one more time. When I differentiate x, it stands alone, it's done, Brooks. But every time I differentiate y, I'm going to differentiate the y, but after I finish differentiating the y, I'm going to write dy by dx. All right? Watch me. The differential of x squared is just 2x. Is x, so it's done right there, so. See it here, so 2x. And then I have 3xy. Sir, that's a product. Oh, you know, sir, because 3x is being multiplied by y. Got you. Product rule says the first. I'm calling my 3x the first. See it right here, so. Times the differentiation of the second. When I differentiate y to the first, I just going to get 1. When I differentiate y, I get 1. When I differentiate 2y, I get 2. When I differentiate y squared, I'm going to get 2y. When I differentiate y, I'm going to get 1. It says 1 times dy by dx. Remember, every time I differentiate y, I'm going to write dy by dx. Plus the second, I'm not differentiating it, I'm just writing it back. Times the differential of the first. When I differentiate 3x, I'm just going to get 3. Then, plus this piece here now. When I differentiate y squared, I'm going to get 2y. See it right here, so? But because I differentiate a y, I have to write dy by dx. Every time I differentiate a y, I'm going to write dy by dx. Why? So every time you differentiate a y, you're going to write dy by dx. Every single time you differentiate a y, you're going to write dy by dx. All right? So now, having, and it's equals, differentiate a constant, you get a 0. I'm going to fix up now. Fix her up. So I remember, you know, differentiation ends right here, so you know, right? We're going to fix up. Then, sir, you're saying to me that every time you differentiate, you have to fix up? Absolutely. Absolutely. You have to always fix up every time you differentiate. All right? This is big school mathematics. When I'm doing the other little foo-foo, calculus courses, then you can't just do anything. But this is one of the highest calculus courses in the institution, big school maths. So you have to do what is right. All right. So the differentiation ends here. So I'm going to just fix up. So this 2x, this is 2x right here. And this 3x times dy by dx, I can't multiply that out because this plus sign separates it. So it's going to be 3y dy by dx. And 3 times y is 3y. And 2y dy by dx. Bam.
Sir, before you move on, explain the y squared differentiation there again, please.
Y squared, this comes in front of it. So you can have 2y. 2y. When I differentiate y squared, I get 2y. But after, anytime I differentiate a y, it does not matter what. Anytime I differentiate a y, I have to write dy by dx. So the differential of 2y of y squared, this 2 comes in front of here, I wrap at the y and I reduce this by 1. 2 minus 1 is 1, so it becomes 2y, which is this.
So y married to dy by dx?
Every single time. Can't separate it. Batty
Oh,
and bench.
so if that was a 3y, that would have become a
3 dy by dx.
No, sir, hold on. Let me answer. All right, so if it was y raised to the third power, that would have become 3y squared dy dx.
Excellent.
Okay. All right. That is what did I mess with my brain. All right, sir.
Excellent. Very nice, honey bunches. All right. Good. So now, when I have all my dy by dx in the stuff, I now need to factor it out. That's the only way I'm going to be able to find dy by dx. I'm going to factor them out. So it means that I have to group all the dy by dx's together. This 2x stands alone. I write it right here. So that 3y so standing alone. So how you know? It is sandwiched between 2 cutoff points. So this 3y stands alone. I write it here. So this 3x dy by dx, you know what? Let me put another line in here just to, for explanation's sake. I don't understand why this thing is just, it's actually moving very slow. And I don't like that. Na, 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 na. All right. So I'm putting in an extra line. Why, sir? Just for clarification or clarity. So these two are standalones. I write them back here. I am grouping my dy by dx's. Sir, you have to group them? Yes, because remember the question says find dy by dx. Right? Find dy by dx. So I'm grouping my dy by dx's. And then I'm taking out the dy by dx because I want to find it. So I'm taking out the dy by dx here. So when I take out the dy by dx from here, I'm going to be left with 3x. See it right here, so? Bam. When I take out the dy by dx right here, so I'm going to be left with positive 2y. See it here, so? Bam. Let's go check it. Dy by dx times 3x is 3x dy by dx. See it here, so? 3x dy by dx. And dy by dx times 2y is going to be 2y dy by dx. See it here, so? Dy by dx. Getting closer. Getting closer. So what I'm going to do now is to isolate. So what do you mean by that word there? We want the dy by dx alone for them on one side. So you see everything else, like them here, I'll go up on the other side. So I'm going to group these two and call them 2x plus 3y. And when I subtract it from both sides, I'm going to get negative 2x plus 3y. And then the dy by dx, 3x plus 2y stands alone. But the piece here, the 3x plus 2y has service days. We don't want it again. So I'm going to divide both sides by 3x plus 2y. See yourself? And that's the end of the question. So I will now isolate my dy by dx. So the implicit differentiation is one where your independent variable, your dependent variable y, every time I differentiate it, I'm going to end up with a dy by dx. So I'm going to first differentiate the function, but having differentiated the function, I'm then going to write dy by dx. When I differentiate the dependent variable x, that does not happen because I'm going to have dx by dy. No. Every time I differentiate a y, I'm then going to write dy by dx. I'm then going to write dy by dx. All right? I have 4 minutes. I know you may have questions. Oh Lord, I don't know how that looks. That one was a little longish. Do I have a
What answer?
No, this one, I was just giving you some options. When I did a question, I was giving you some options. I don't want to do that one just yet. I am going to, this one looks a little bit more sane. Long but sane. So let's just do this one quickly. I'm just going to run through it so you can see what is happening. Oh, sir, but there's another point to the question. No, it says find dy by dx at a particular point. Don't worry about this part of it yet. Let us try the differentiation of this implicit function. So x to the 4th times y is a product. X to the 4th multiplied by y. Let us do this one quickly. The first, x to the 4th, see that so? Times the differentiation of the second. When I differentiate y, I get 1, but again, write 1 dy by dx. All right? Plus the second, I write it right here, so times the differentiation of the first. When I differentiate x to the 4th, I'm going to get 4x cubed. See here? 4x cubed. This piece done. Then I'm going to differentiate here. I'm going to differentiate here. 4x cubed y is also a product. 4x cubed, my first term, y, my second term. Watch it. The first, 4x cubed, see it here, so. Times the differentiation of the second. When I differentiate y, I'm going to get 1, but because it's y, I must have 1 dy by dx. Then plus the second, so the second here y, bam. Times the differentiation of the first. So when I differentiate the first, I'm going to get 3 times 4 is 12x cubed, 12x squared. I'm going to have 12x squared, bam, right here, so. Right? And then, no, that is finished. And then I'm differentiating this piece. Minus, here the question now, unique. 6 times negative, 2 times negative 6 is negative 12. Why? See here? Negative 12y. But because it's a y, I'm going to have dy by dx. And it's equals to a differential of a constant 12, which is equal to 0. All right? So having gone through that, I'm going to fix it up. This is going to become x to the 4th dy by dx. See it right here, so? And this becomes 4x cubed y. See it right here, so? And this becomes 4x cubed dy by dx. See it right here, so? This becomes 12x squared y. See it right here, so? And this is still negative 12y dy by dx. I'm rearranging. So by rearranging, to put all the dy's by them together. So this x to the 4th dy by dx is right here, so. Then we're going to haul that one inside of it. See it right here, so. Then we're going to bring that one in front of it, beside it right here, so. And then the numbers that stand alone, or the other terms without the dy by dx will go together. Like 4x cubed y, see it right here, so. And 12x squared y, see it right here, so, equals 0. And then I'm going to factor out my dy by dx right here, so. See it here, so? I'm factoring out the dy by dx. So we have my, I'm going to have my parentheses. And then I'm going to have my x to the 4th, 4x cubed minus 12y. Watch this magic. We're putting all of them something here, so, together. Look at it another way. And which is what I have here in blue. That's exactly what I have here in blue. Because I grouped it and I want to show you both methods. That's exactly what I have there in blue. But let me show you right here, so. Where am I, Lord? Let me show you right here, so. So I have positive 4x cubed y. When I subtract it from both sides, I'm going to end up with a negative 4x cubed y over this side. See here? This negative times this will give a negative 4x cubed y. This is a positive 12x squared y. When I subtract it from both sides, I'm going to end up on this side with a negative 12x squared y. See here? This negative times this positive will give a negative 12xy. But I just put everything together as one. Right? So if you want to take them individually, your choice. All right? And then no, I'm going to have this. And all I'm going to be doing is dividing both sides by what is here. So I'm going to end up with this x to the 4th plus 4x cubed minus 12y, all under that something here. So the differentiation ends right there. So the fixer-upper ends right there. And what ends there is going to be now, evaluate at a point. When you say x comma, when you say 1 comma 1, it means x comma y. The first number is the x and the last number is the y. So everywhere inside here, so I say x, I'm going to put 1. And everywhere inside here, so I say y, I'm going to put 1. And when I put it in like so, and I put it in like so, and I put it in like so, I end up with my final answer as 2 and 2 sevenths. 2 and 2 sevenths. 2 and 2 sevenths. 2 and 2 sevenths. And that's the end of the class. All right. You need to run up to the other class. One final thing I'll say to you, when you go on to Edico, you actually will see your grade for your mid-semester test. I am yet to post the other grades there, so you can look at that and start to worry a little bit more. There are about 5 papers that I need to upload to it. So yes, so some people have already seen their grade on Edico because I put it there. I am going to just verify those grades so you can look at it. So if there's any change to the grades that you see on Edico, it means that because I have verified the grades. All right, so you can log on to your EdicoSoft. You can go to my grade and you will see what percentage you have so far with your mid-semester. Have a good one. See you on Thursday, God's willing.
All right, sir. Yeah, I know you're gonna fix this up. But for me, I would like to go over it.
Over what?
This? Yeah.
So yeah, man. Absolutely. No. It's so quickly I went through this because I went through it because I want you to see the recording, listen to the recording as soon as it becomes available. So when I write those questions, you can try those on your own. And when you have difficulties now, then we discuss those when we come to class next Thursday all being well. Yeah, man. Absolutely. Absolutely. All right. So we'll talk then here.
Stop share out of the pot.
Yes, so please, bless your heart. It was actually served to me. Anyhow, we'll talk. Have a good one.
Nice, sir.
Wonderful.
Yes, sir.
Yes, sir.
Yeah, easy.